You know, we're familiar with the ordinary miracle of the Neuse River wastewater treatment plant taking Raleigh's wastewater and turning it into all but drinkable water that flows into the Neuse River. But what happens to all the stuff that comes out of that water to get it so clean? We're talking about sludge, about biosolids. And to understand, we turn to one of the most beloved characters in wastewater management. No, not famous sewerman Ed Norton, but Carl Spackler, beloved groundskeeper of Caddyshack, planning attacks against golf course gophers with explosives he fashioned while sitting in front of bags of milorganite. That's milorganite. Milwaukee, organic, nitrogen. It's poop! It's the poop of the people of Milwaukee. Safe, useful biosolids left over from Milwaukee's sewage treatment. Golf courses nationwide use it for fertilizer. You probably have some on your golf shoes right now. And the people of Raleigh put their own biosolids to just as good use, though Raleigh Sludge, Liquid Biosolids, and Raleigh Plus, the pasteurized combination of Raleigh's biosolids and lime kiln dust, go to agricultural rather than recreational uses. This is nothing new. Since the dawn of time, humankind has been putting its waste to work. The Greeks, the Incas, the Chinese all used manure, including human waste, to fertilize crops. The Romans even used the ammonia from stored urine to clean their togas. In Raleigh, it starts at the Neuse River wastewater treatment plant. Raleigh Reuse Superintendent Tim Woody explains how 60 million gallons per day of dirty water turns into tens of thousands of tons of black gold.
It comes in through what we refer to as the headworks, and then it moves into primary treatment and settling. We move into aeration. It moves into secondary clarification. And this is actually where you'll see a lot of the sludge at this point will move forward into these process units.
The water moves on through the remainder of its treatment until it flows clean and safe into the Neuse. Some of the sludge, now activated with beneficial bacteria, flows back to the head of the plant to activate the next aeration basin of wastewater. Waste sludge goes through one of three different stabilization processes. One is digestion, in which the bacteria reduce volume by digesting each other.
The solids are left behind to go through a series of digestion processes. We have uncovered digesters. We have thickening processes here.
Sludge spends a month or so in 2.5 million gallon covered digesters, further reducing its volume. This digested, stabilized sludge is called Class B biosolids, a liquid product applied by the Terrigator, a magnificent beast of a truck that sprays Class B biosolids onto permitted fields.
Probably about 10% of our daily production goes into liquid biosolids Class B, which means that wherever we put this material on a site, it has to be specifically permitted for use on that site. So a farmer may choose to have one of his fields permitted. We will go out there, we will analyze the site, we will look at the crops, we will look at the lay of the land. If it meets certain criteria, then we can request it to be added to our permit. And then each year, or on certain intervals, we will apply liquid biosolids Class B to that site, and he'll basically receive the benefit of a fertilizer.
Ooh. Big trucks fit into the other stabilization processes too. Undigested sludge can also be pumped to the dewatering room, where it goes through belt presses and becomes what is called cake. From dewatering, about a third of the cake goes directly to hoppers, from which local composters take it and mix it with other products to create the safe compost you buy in your local hardware store. But most of Raleigh's sludge, about 60% of total biosolids, goes up that conveyor, mingles with lime kiln dust in an enormous mixer, and turns into safe Class A biosolids through pasteurization.
That's exactly what happens. We use lime kiln dust. We raise the temperature to 7 degrees Celsius for 30 minutes, and it has to maintain a certain pH for the next 22 hours. We do our sampling at our laboratory for metals, for nutrients, for coliforms, and once all those criteria are met, then we can distribute it into the agricultural market.
The material is mixed while it conditions. A yellow flag identifies the batch. Green means load it up and spread it out. Farmers can apply it as they would any other soil conditioner or fertilizer, with no special treatment. Which isn't to say biosolids are always handled right. Practices in Raleigh caused environmental problems and in 2002 required investigation and corrective action.
Federal regs came out of the mid-90s. Before that, there were no regs, and we went by what maybe the university may have told us we should do with it. Once the regs came out, we implemented different programs to monitor these constituents of the biosolids.
The plant was for a time prohibited from spreading biosolids on its own 1,000 acres of farmland. But new leadership quickly put the Neuse River wastewater treatment plant back on the right path.
We learned that we can't put out as much material per acre, per unit area as we used to. So we made a very conscious effort to go back, look at not only where we may have fallen short, but also where we might be able to improve in the future.
In 2003, Raleigh became the first system in the Southeast to join the National Biosolids Partnership, installing an environmental management system and committing to regular third-party audits. As a result of years of effort, Raleigh in 2012 plans to seek permission to again begin applying biosolids to its own farmland. It also hopes to soon make Raleigh Plus, its Class A product, cheaply available to residents in bags as convenient to use as those in hardware stores. So that's how you turn a daily 60 million gallon problem into healthy soil, improvements for farmers, and eventually a product available to Raleigh's water customers themselves. 90% of Raleigh's biosolids don't go into landfills, but find beneficial use right back into the earth. That's not just good. It's in the hole! It's in the hole!